All right, within triangles, we can draw different types of segments. There's 4 that we're specifically going to talk about. The first one is an angle bisector, which we have already talked about angle bisectors. But now if we look at it just within a triangle, all right, it's going to specifically be a segment that is drawn inside the triangle that bisects an angle. All right, you're going to see the little arcs like you see here, and they are labeled the same. That's how you know that that angle is split in half. All right. It will always come from one of the vertices, and then it just connects to the opposite side somewhere. But what you're looking for is the markings to show the 2 angles are congruent. The second one is called a perpendicular bisector. Again, we've talked about the word perpendicular and bisector. So this segment needs to do both. All right, it's a segment drawn inside your triangle, and it has to be both perpendicular and it has to bisect one of the sides. So what you're going to see is you must see either that the tick marks are there to show that the 2 smaller sides are congruent, or you need to be told that this point, whatever it's labeled, is a midpoint. Because just knowing it's a midpoint without the tick marks, you should know that they would be congruent. The other thing you need to see, obviously, is the box, because it has to be both perpendicular and it must bisect. Notice this segment, when drawn, and they've drawn it a little bit extended through the triangle, all right, does not necessarily connect to this vertice. All right, in fact, it's the only one that we're going to talk about that does not necessarily go through the opposite vertice. All right, a median. All right, you might remember that word with like mean, mode, median, range, and median was always the middle number. So thinking along those lines, this is a segment that we're going to draw inside the triangle that connects a vertice, all right, to the midpoint of the opposite side. So again, you have to either be told that this is the midpoint, or you'll see the tick marks drawn. All right, the difference from the one above is that this one definitely connects to a vertice, where your perpendicular bisector does not have to. Okay. And the fourth one is the altitude. And we use the altitude when we are finding area of our triangles. The altitude is a segment drawn from a vertice that will be perpendicular to the opposite side. All right, so you're going to see the box. All right, so it's going to go from a vertice straight down to make the right angle. Now, an altitude, depending on what type of triangle, can be inside, as it's showing here. Could be outside, as we're showing here, this dotted line going from vertex A. In order for it to be perpendicular and come straight down, it's going to fall outside the triangle. It might actually be on the triangle. If I go from vertex A, notice I'm just tracing one of the sides. So this is on. All right, what do we notice about the different types of triangles? Well, this one is going to be acute. It's an acute triangle is when your altitude will fall inside. Okay. It falls outside. If you notice, this angle right here is obtuse. So in order for it to fall outside, you'd have to have an obtuse triangle for that to happen. The only way that it's going to fall on the circle is if the triangle itself is a right triangle. All right. The altitude is the only one of these 4 that can happen, inside, outside, or on. The other 3, angle bisector, perpendicular bisector, and median, all are inside your triangles. All right. Now, isosceles and equilateral triangles. We know that those are special. All right. If I look at this, I can tell those are my 2 congruent sides. In isosceles and equilateral triangles, if you are drawing these segments from the vertex angle, and remember the vertex angle is the one that is opposite your base. If I draw in an angle bisector, what is going to automatically happen is not only does it bisect the angle, but it will be perpendicular to the opposite side, which makes it an altitude also. Not only is it perpendicular, but it also bisects the base. So I've got an angle bisector, I've got an altitude. Since it's going to the midpoint, I also have a median. And then since it's perpendicular and it bisects, I've got a perpendicular bisector. All right, so in an isosceles triangle, only from the vertex angle, the segment that we draw in, all right, can be all four at one time. And then, of course, since an equilateral triangle is a special kind of isosceles, all right, and I wanted to draw in my angle bisectors all the way around. Now, this is a sketch, but if it was as accurate as I could be, all right, all of these would be so no matter which corner I came from, those would all be the same. Altitudes, perpendicular bisectors, medians, and altitudes. The other neat thing, and again, mine's a sketch, I'm a little off, is they actually all meet in the same point. All right. They should all, if we drew this in accurately, they would all intersect at a same point. And that point does have different names depending on which segment we're looking at. It might be an incenter, a circumcenter, a centroid, or an orthocenter. That used to be part of our curriculum, but with this virtual learning, we've taken that part out and just want you guys to be able to identify these four special segments. All right, so that's what you'll be doing today. All right, time to practice.